What I want you guys doing before we go ahead and get started is we're going to be talking about velocity and speed and what their differences are. So, what I want you to do right now is have a notebook and a pencil. And remember that we'll be checking your notes to see who completed them the next time I see you guys in class. Cohort B, I sent you guys home with some notes. If you didn't get them, I'm also going to post them in Google Classroom. And Cohort A, if you were not in class, you can get the notes when you get into class next week. If you are in Cohort A and you're going to be present, you'll get these notes in class. So, what I want you to do is on your paper, answer how would you explain what the word distance means? And how is it different than displacement? So go ahead and pause this video. Take about 2 minutes to tell me what your definition of distance and displacement is. And for cohort B, try to use it without using your notes. Also, cohort A, try to not look it up online. I just want to see what you guys think of it and what it is. Okay. And so when we are talking about speed and velocity, we have to talk about distance and displacements. And so we have to look at the difference between distance and displacements. Okay, and so if we look, let's say we have somebody taking a stroll. All right, and so this bluish purple path is the path that somebody took. All right, and so they didn't travel in a straight line. They kind of took a right, a left, a right, a right, a left. Okay, and so they came to an ending point from their starting point. So here is where I started in blue. Here is where I ended in red. Well, your distance is the actual path that you took and how far that path is. Okay, the displacement is only looking at from where you started, where you finish, and it's going through the quickest route. It's taking the quickest line path from point A to point B. Okay, and so I want you to look at your definitions and see how close you guys were. And so if we're looking at it, distance is the total length traveled as you go from one point to the next. So the distance accounts for all movement in between the start and finish. So if we look up here, you can see it accounts for every part of that motion traveled. Okay? And so when we look at displacement, it's just the length between the 2 points, and it does not consider the path you take to get there. It's always a straight line from start to finish. So remember, displacement is not path dependent. Distance is path dependent. Okay? So let's take an example. You take one lap on a track, and that's a distance of 400 meters. You start and finish at the same point, so the displacement is 0. So if I go ahead and start my runner, let's just say the start is here, and I take him all the way around a 400-meter track. Okay, well, we know a track is 400 meters, so the distance he traveled is 400 meters, but the displacement is going to be 0 because he finished where I started. Okay, so it's like saying, well, let's say we started at the 0-yard line. Well, what happens, and I'll go ahead and draw the other 0-yard line. What happens if we draw or go 100 yards, and then I turn around to go 50 yards and I stop? Well, the distance traveled would be 150 yards. My displacement is going to be 50 yards to the right, okay, or 50 yards in front of us, depending on how you're looking at it. Okay, so remember, the distance is the whole distance traveled. The displacement just wants to know from where I started to where I finished. Okay, so looking at your speed notes. Okay, speed is how quickly an object is moving. So if I say, well, how are you faster than somebody else? What two things do you have to measure? Okay, and so when we answer that question, it's the rate at which an object covers a certain distance. So distance is part of speed. Okay, and the rate at which you cover that distance, so time. So when you think of distance, it's going to be distance divided by time. So for example, a car moving at a high speed is covering a large distance in a short amount of time. Well, the faster the car is moving or the greater the speed, the shorter the rate or the amount of time. Okay. And notice there is no direction given in speed. So I can say I'm going 25 miles per hour. I mean, you guys don't know if I'm going north, east, south, or west. Okay. So, how is speed measured? Well, we use speedometers. Okay. There's a lot of different things that we can use, but speedometers are usually what we use to measure speed. Okay, so the speed formula, speed is the distance traveled over a certain amount of time. And so I want you to write this, speed equals distance. And I'm going to go ahead and draw its distance divided by time. Okay, speed is distance divided by time. This is your formula for speed. Velocity is how fast an object is moving in any given direction. So this is where we go back to scalar and vector. Okay, velocity is a vector quantity, meaning it's not just how fast you're going, it's how fast you're going in any given direction. Okay, so direction is crucial. Okay, so it's the same as speed, but it also tells you the direction which an object is moving. Okay, and so it actually is based on the displacement. But right now we're going to keep it simple, and our distance is always going to equal our displacement. And I'll show you examples in class on what I mean by that. But I'm also going to show you instances where speed does not always equal your velocity. Okay, and so I can have a zero velocity, but I can be going 100 miles an hour. And so some of you are looking at me or thinking, well, I don't understand that. And so we'll go over those examples when you get in class. Okay, and so we'll talk about it. So an example that we have is a car is traveling 65 miles per hour east. Now, velocity, and so I want you to write this, velocity actually is displacement divided by time. But right now, for the purposes of understanding the constant, the concept, not constant. We are going to make sure that the distance and displacement stays the same. Okay, and so we in class are going to make sure that my distance and displacement stay the same. All right. As we move forward, we're going to go ahead and give you instances where my distance and displacement are not the same. So this is your equation. Speed is distance over time. Okay? Or velocity is distance over time. Okay? And so when we do this, most times we're going to be using meters. Sometimes we'll use centimeters. Okay, time is always going to be in seconds in this class. Sometimes we could use minutes, okay, but seconds seem to be the best interval to measure. And so when we go ahead and get the velocity, it's going to be meters divided by seconds, meters over seconds, because distance is over time, meters over seconds. Meters is a unit of distance, seconds is a distance of time. So we just keep it in the same parameters of the equation. Okay, so what happens if I give you an equation? Well, an object is traveling east for 10 meters in 2 seconds. What is the object's velocity? Well, we have to jot them down. Okay, always write down what your units are. And so I will always put velocity equals distance equals, and time equals. And the reason I'm putting those three is because those are only the three variables that we have in this equation. Okay? And so when I look, I'm going to go ahead and circle everything that I need or underline. So I have 10 meters in 2 seconds. Well, if I look at those variables, 10 meters is that velocity, distance, or time. And so your answer should be, well, Mr. Sasty, meters, that is a distance, and you're right. And then you have time, which is 2 seconds. Okay? Well, you're like, well, Mr. Sasfi, your velocity, we don't have it. But if we look at the equation, it says, what is the object's velocity? So right now, I don't know what my velocity is. So that is what I'm solving for. Okay? And so when I'm going ahead and going over the velocity, or I'm going over something in this equation, I am always going to have I am going to go ahead and always have one unknown. So when we're given an equation, we're always going to have one unknown. And right now our unknown's velocity. You are always solving for the unknown. Okay, so when I look at this, my unknown has to be by itself. So velocity is going to equal distance over time. And so I just plug those units in. So velocity is going to equal 10 meters over 2 seconds. And so I will go ahead and write this out. So velocity equals distance over time. Okay, and so I just plug these in. Well, distance, that's going to equal 10 meters. Okay, and it's over time, which is 2 seconds. So what is 10 divided by 2? Well, that's going to equal 5. But now I want you guys to notice on just the units. Okay, notice how meters is over seconds. So my units is going to be meters over seconds. Okay, and so another way we'll see this is 5 meters per second. Okay, and so that is going to be my velocity, but it's not velocity yet. Okay, this is speed. So I want you guys to remember what makes velocity different than speed. And if you answered it's the direction, well, you're right. If we read again, an object was traveling east. So my velocity is 5 meters per second east. Okay? If you do not give me the direction, you've given me speed, and it will be marked incorrectly. Okay, so I want to know the vector of velocity. Now, looking at it, I've gone ahead and posted in here. It's 5 meters per second east. Well, what happens if I give you guys a problem where I'm not asking for velocity? Okay, and so you guys have to think, well, what variables do I have, and what is my unknown? And so I'm going to go velocity, distance, time. And so, again, I have to break down a problem. So if an object travels west at a velocity of 5 meters per second, so right now it's giving me a velocity of 5 meters per second, and I travel for 5 seconds, how far did I travel? Well, I know 5 seconds is time, and so I'm going to go up here to time and put 5 seconds in. Well, it also gives me velocity of 5 meters per second. So technically, it's asking what is my distance because it hasn't given it to me. And so if you look at it, how far did it travel? And so if I'm asking you how far did you travel, I'm asking you for a distance. So I don't know my distance. But I have an issue now. The problem is I have velocity by itself. I have to get whatever my unknown is by itself, okay? And so I have to use this mathematically. Well, because distance is on top of time, it's being divided, the only way to get distance by itself is I'm going to multiply by time. So I'm going to multiply by time. So it's going to be time over 1. And so this time is going to cancel out. And so it's going to be multiplying by time. And I'll put it a capital T so it makes it easier to see. Now, if I rewrite this, what this comes out to be is time times velocity equals distance. So if I just turn this around, I could also just say distance equals velocity times time. Okay, or d equals v times t. So now if you look at my new equation, I have d by itself. Okay, and so I want you guys to write down this equation. It's d equals v times t. And so there is an equation for velocity or for time as well. And so I'm just going to have you guys write it down. Okay, and so time equals distance divided by velocity. Okay, so these are the two equations that I want you guys to write down. And we'll talk about in class how you guys can break them down. And so I'm going to go ahead and put a box around them. These are also two that you're going to have. And if you notice, we have an equation for velocity, time, and distance. So distance equals velocity times time. Time equals distance divided by velocity. And velocity equals distance divided by time. Okay? And so we're going to, since we're trying to find distance, we have to use the equation that has distance by itself. So the equation is going to be distance equals velocity times time. And so when I do that, d equals 5 meters per second times 5 seconds. Okay? And so when we do that, well, 5 times 5, your distance equals 25. Now, some of you are going to be looking at this as if, what do I do with my units? Well, I'm going to go ahead and write this out. So I have 5 meters over seconds, and I'm multiplying it by 5 seconds. And anything unit-wise is over 1. So technically seconds is on top over here and it's on bottom. These end up canceling out. Okay? And so what I'm left with is m over 1, which is just m. And if you think about it, my unit for distance is meters. And so it's going to be 25 meters. And if you're ever getting confused about what unit to use, okay, just kind of look at the equation or look at the units that you're given and think, well, what is distance measured in? Well, it's measured in meters. It's not measured in seconds, and it's definitely not meters in seconds. It's just meters. Okay, and so at this point, I just want you to be able to try to differentiate what units you're going to use. Okay, and in class, we'll break it down on how to calculate for those units, especially when we're going from something like velocity to distance or time. Okay, so again, my distance is 25 meters. Okay, and so what I want you to do is make sure you take these notes, submit them online, and then go ahead and start your practice problems online as well.